So good morning, evening, afternoon, everyone. I just want to introduce the remote interns who have been working with us this summer. So there are seven of the students. They are in undergrad, second year, third year, and then we have a high schooler also, spanning from India, many of them, and also the in Silicon Valley from San Jose. So without much ado, I would like to people to just get started. We will have 7 minutes per students, and we have a whole bunch of people joining in, and coming out. So I will call out Akshay. You are there, so please start your presentation.
Yes, sir.
And all the faculties who have joined, Marco, Mike, and many others, I will not be able to say, but you will see the people recognized who are helping here. Yeah, Akshay, please go ahead.
Sure. Yes, sir. So, hello everyone. Myself Akshay. I work with Biplav sir over the topic of face mask detection. So, about myself, currently I am third year undergraduate from IIT Kanpur, majoring in computer science. I am working with Biplav sir from January 2021 to current. Our mentors are Biplav sir and the Kaushik sir. My major area of interest is computer vision, deep learning, and the cryptography. And during the internship, our main focus is to create tools so non-tech users can also use them, and the explanation part of the object detection. So this is the abstract of the whole project. So what we did, we created a tool, mask adherence estimation tool made, which provide the two things. Firstly, the how much adherence in the image people are wearing the mask, and the respective explanation for each of the faces to make the system reliable. So the challenges that we faced are like, firstly, as we all know that deep learning models are usually based on the quality of the data. So but the publicly available data is not robust, as well as not a good amount to make a good predictor. So firstly, we tried to collect a robust set of images and manually edit them to make our system more robust. And to make the robustness, we also apply the we experimented with several data augmentation techniques and chooses a few best of them for the final training of our model. Also, we experimented with various structures of the object detection so that out of them we can use the most robust one and the most reliable one. The third point is like, we get the output. Then how can we say that it is correct? The model predicts because of its uh, correctness. So we try to inbuild the end-to-end system in which we are providing the explanations for the prediction also for its reliability. And the last point is like, we have so many open sourced code, but the non-tech users don't know how to run it. So we try to come up with a tool that the non-tech user can just upload the image, and he can fluently use it. So that's the challenge, and that's the whole project workflow. Like, uh, it's for the final tool that we created as an object detector. We use the YOLO because of its lightweight and high training efficiency. And for the explanation, we come with two explanation methods. One is line, second is rise. So the general idea is to get how much perturbation is affecting the final output. And for getting it converted for the object detector, we try to define a similarity score which collaborate both the bounding boxes as well as classification under one topic. For the rise based, we will have a saliency map as an output, and for the line we will have superpixels as an output. The underhood of rise is to randomly generate mask and get the perturbation, while for the line it firstly segment the images into the superpixels, and then it try to learn a linear model based on how much superpixel contributed to the final predictions, and we expected the top three, the most weighted top three superpixels as a final output. So here are the few results from our model. Firstly is the original image. Then we are providing the output for our model. The red ones are showing that the person is not wearing the mask, and the green ones are showing that the person is wearing mask. So first image is showing that we have added noise to it to check whether the model is robust toward noise or not. So it is able to classify it correctly, and we can in the third image we can see like even for the different poses of the face, our model
Akshay,
work
two
quite well.
minutes. 2 minutes left, Akshay.
Okay, sir. Okay, sir. So the third image is showing the rise based explanations for the selected target that are written at the last, and the last row is showing the rise based. Here are the few evaluation matrices that we tried to come up for the comparison of the different methods. Here is a short demo of the tool. So firstly we select an image, upload it. We will get the bounding box. We will have to choose the which bounding box we have to define. Then we will for the line we can vary even for the superpixels according to its weight. uh, this example also shows that like just covering the face will not fool our model. So for second it's for multicursor. So that's the model, and the future work is that like the past work we did is just for the mask explanation. Can we do it for any general object detection task over the benchmark data sets like MS Coco, etc.? So we are working over that. Here are the few results for both of our explanation methods over the randomly chosen image of the MS Coco data sets, and respective object name is defined at the last. So
Thanks,
that's all from
Akshay.
my side.
Yeah. Thanks, Akshay. I will request people to use chat if they have any question, and at the end we will have about 10 minutes for asking more questions. But this is just supposed to be a teaser. Okay, we have some papers and things like that which you can use. Next, I will call on Rhythm to present his work. Please feel free to ask questions on the chat. We can use that.
So can we reply in the chat also?
Yes, please.
Yeah, is it visible?
Yeah, we can see the presentation.
So, yeah, so my summer project was about the chatbot generator for visitors at a university and proving their effectiveness. So, I am Ridham Hajra from Computer Science and Engineering Department, third year, NIT Durgapur, and my mentors are Tarmo and Professor Sandeep Kumar from IIT Roorkee and Professor Biplav Srivastava. And my interests are machine learning, deep learning, data visualization, front-end development, etc. And the background of this project was about creating a chatbot for the universities and testing the user preferences while uh, having that conversation and doing a random quantumized style for the testing of the chatbots. So the problem was that a lot of students come to university websites regarding their queries about the website, and the people of staff, those who are there, they manually answer those questions, and usually that takes a lot of time and it gets delayed easily. So we are making a chatbot that will give out that answers instead. And for that, our approach was firstly creating a chatbot generator, and for that we needed the specified data set of question and answer. It was in English for general sense, and then it was trained using neural network, and then we need to test its effectiveness by doing A/B testing. Like we will give out two versions of the product, and we'll take the user preferences, whatever they have liked, and then we will validate it by conducting randomized control trial. And for that we need to record the chatbot dialogues, and then we will do the analysis of that. And for that, this is what we have done. As of now, we have made 3 question answer set for different universities, one for South Carolina, one for NIT Durgapur, and one for IIT Roorkee. And the chatbot is made using a RASA framework, which is the backend part is on Python, and the chatbot got a F1 score of 0.9983, and we used about 50 intents, like 50 set of question and answer. And also we got the recordings of the chat so that we can analyze further in future. And as of now, we are stuck with the deployment part because of the few issues with the RASA framework, because it is a very new technology. It just came in early 2020. So we are working on that, and further we have to do the randomized control trial. So I'm giving a demo for the chatbot now. So this is the home page of the website, and this is the chatbot. And firstly, we'll get a welcome message like this, and then you can ask, suppose you want to go for lunch, and you can ask where to get lunch, and then it will give you the answer. And here is the link. If you click on the link, it will redirect it to your university website. There are restaurants, whatever you have liked, you can see there, and you can return back. And if you found this useful, you can just click this button yes, and it will say carry on. And you can maybe ask another question, like what is my application status, and then it gives this answer, like please contact your department consultant, and you don't like that answer, so you say no. Then it will ask you to reframe the question. Similarly, this is the work, and going back to the slides, and what are the things in future. So we are trying to make this thing auto generative, because we have 3 university in mind, and we have the data set as well. So we have to do the coding part to make it auto generative, and then there will be the testing, and we have in future plan to present it in like in paper form in AI or NLP conferences. So that was the thing. Yeah, that's it.
Thank you, Rhythm. And if you have any question or clarification, you can ask on chat. I will call upon Prasad to present his ongoing work.
Is my screen visible, sir?
Yes, Prasad.
So, like, my project is about generalization in text for common sense. So I'm Prasad. So I'm currently pursuing fourth year of MSc Data Science and Integrated course from PhD College of Technology, Coimbatore. So my internship duration is about 6 months. So I'm currently completed 3 months of my 6 months duration. So my mentors are Professor Biplav and Dr. Kirti from BMR and Kaushik. So my areas of interest are machine learning, data mining, NLP, and graph mining. So like introduction to like TWC is about textual common sense. See, textual is an like open source engine that can generate and actually simulate text-based games. So like it is used to train RL agents to learn natural language understanding and sequential decision making. So it is developed by Microsoft. And later, textual common sense is built upon textual to generate problems that actually require common sense. So, like you can see here, an agent sees an observation that's about the environment it is in. So, it gives this observation as a text, and it has to perform an action so that it gains a perfect reward. So, the goal of this agent is to clean up its environment. It's like a home environment. You can be in your backyard, you can be in your kitchen, or in a hall or something like this. So you have to, you will get an observation from time to time, and you have to clean up the environment. So this is an example. So this text-based games are actually partially observable MDP. Here these text-based games have combinatorial action space. So if I have a forward action to perform, if I have a vocabulary size of 700, then I have to perform 700 power 4 possibilities. So that would be around 2.4 billion uh, cardinality of the action space. So we cannot explore the whole action space. We have to efficiently explore that space. So we use common sense to do that. So concept is a knowledge graph that helps us to reduce the exploration here. So we have to clean up the kitchen. So this is the introduction to textual. So my problem is like generalization in textual common sense. So generalization is like refers to the agent's ability to uh, adapt and perform well under some unseen circumstances. So like it has to adapt to a new unseen object and environment, and has to perform well. So, if for example, in training phase, my agent performs, put apple in the basket, this action. So, in testing phase, if I come across a similar object like apple, I should be able to generalize this action to that object and container. So, this is the problem that I have to do. Like, if I come across an orange in the basket in a similar situation, uh, my agent must perform the action, put orange in the basket, and get the reward. So, this improves the performance of the agent to new unseen objects in the test phase. So like we used ConceptNet in solving this problem. So ConceptNet is a multilingual knowledge graph. So it is like it's a knowledge graph, and it's also used for NLU, natural language understanding. It also has word embeddings. So we use this ConceptNet knowledge graph for this generalization purpose. So like we thought that similar objects can be generalized. So to find similar objects, we have to find node similarity statistics or statistics from the knowledge graph. So we calculated the node similarity statistics like Jaccard coefficient, Salton similarity, so Sorensen similarity. So we found the results, and the results are not satisfactory with these statistics. So we decided to use these pre-trained word embeddings. So I will show the results. So we use 3 pre-trained word embeddings to compare the difference in similarity of objects. So we use fast text, cloud, and concept and number batch word embeddings in this experiment. So these Jaccard, Sorensen, Salton are the raw graph statistics, and these 3 are word embedding and neural statistics. So like we have this table now. So we find this dissimilar objects having a lower similarity, and a similar object like chicken and barbecue is having a higher similarity. So this is a kind of noise workbench and work table. See, we are also have to be aware of these kind of noises that can come from the word embeddings. So we are experimenting this, finding similar objects and trying to use this concept net efficiently to perform the action. So the roadmap of this project, like I had 3 sprints. 6 months is divided into 3 sprints. My first sprint about ended on 13 July. So understanding this current code base and understanding the textual common sense. And I am currently doing my sprint 2. So I'm in the bit of sprint 2 generalization in textual common sense, the current problem that I'm addressing. So after this, I'm the last 2 months I will be trying to solve this problem, adaptation problem. So if you have given different resources and different objects, I have to be robust, produce a robust result in this environment. So that's the end of sprint 3. So this is the project plan. So thank you.
Hey, thanks, Prasad. Again, if you have any questions, please feel free to ask in the chat. We will have a dedicated question time at the end. Uh, Now I would like to actually call in Gaurav to present his work.
Is my screen visible?
Yes,
Yeah,
it
it
is.
Okay, thank you. So the topic on which I worked on this summer here at the internship is to make a tool and data resource to explore the instability of sentiment analysis system. So a little bit of introduction of me, about me. I'm Gaurav Mundara. I'm currently studying in pre-final year of BTech. I'm majoring in computer science at IIIT Naya Raipur, but I'm currently studying virtually. So here my internship duration was 3 months. I joined in mid-May and I was working till the start of August. So my mentors here were Professor Biplav and Kaushik sir. My areas of interest include NLP, deep learning, ML, and a bit of web development. And the context of internship here was to do research in NLP and analyze the instability of sentiment analysis system, as stated earlier. So let's move to the problem that I explored. The main thing that we needed to do was to build a system to visualize the trustworthiness of sentiment analysis system. For that, we used total six SAS. The two were off-the-shelf sentiment analysis system like TextBlob and Vader. Along with that, we used various deep learning based systems like CNN, GRU, LSTM, and Distilbert. So what we had to do was to understand the anomalous and bizarre behavior of sentiment analysis system with respect to a gender, or if we change a pronoun or a noun in a sentence template, then it shows different results for different sentiment scores. So we just visualize and we calculated scores and then visualize using a framework. So the system consists of input text and the output is sentiment scores. And I created a visualization tool so that we can clearly see what's happening inside. So these are the results. It will be better if I showed you the model. Yeah. So we have named our tool as Rose tool. Um, okay. So we have total 3 modules: explore emotion by words, explore emotion by pronoun, and proper noun. And also we have given a link to access the data resource. So first, let me jump to explore emotion by words. So the total we have used 10 words in the sentence templates, 5 of which, as you can see on the right hand side, are positive words and the left hand side are negative words. So let me click on any word. Say for example, I click on glad. I get an graph. So the x-axis here denotes the 80 sentences. 80 sentences on which we calculate having the word glad in them, on which we used various sentiment analysis system. So if I click on all the systems, so first of all, let me click on TextBlob, Vader, and Distilbert. So we can see that they are all consistent for every sentence. To see which sentence the particular data point denotes to, we can hover on the point, and at the bottom here we can see what sentence denote. So this sentence denotes my aunt made me feel glad. So for this three, the system is consistent. But on the deep learning based sentiment analysis system, we can see that the we get anomalous results. So we have sentiments ranging from positive and negative. So for glad, all the sentiments should be positive. Sentiment score should be positive, but it is giving negative sentiment scores. So it is quite. It shows that these systems are quite unstable. So same is with all other 10 words, and we have also calculated and plotted the average sentiment scores for each of the 10 words. This was the first part of our tool. In the second part, we have explored emotions by pronouns. Here we have given different options for male and female. So if I click on all the males, for example, one second. Yeah, so I clicked on all the mails. We can see that here we have used different templates. So we have 4 sentence template. You can see at the bottom, person subject feels grim, person subject made me feel grim, I made person object feel grim, and situation make person object feel grim. So what we have done is we have taken average sentiment score from 10 words. Instead of person object, we have used 10 different pronouns like him, father, husband, boyfriend, something like that. So we have used 10 different words and we have plotted what we got the average sentiment score for this particular sentence template. So as we can see that for text blob, Vader and Distilbert, it is constant, but the same thing for CNN and the other machine deep learning based model, they are quite haphazard. So if I click on refresh, this was one type of instability. The second type of instability is the gender bias. So for a given sentence, suppose I made person of I made this is for I made her feel grim, I made him feel grim. So this two are supposed to give same sentiment score, and these two graphs are supposed to superimpose on each other, but it is showing that most of the sentiments are not superimposing on each other. So this is what shows the gender bias. Also, this is the same thing. We have, instead of using him or her, we have used various Afro-American names or Indian names and various other things. Here's the link to access the data resource. So let me show you, for example. These are the type of sentences that we used. This is one data block. This 10 sentence is one data block, and we calculated the average sentiment score for this, and we plotted it on one data point. So this is it in the demonstration part. And what we have done is we have recently submitted a paper at the ACM Scots Combat demo track, and we will also be aiming for AAA as demo track. Also in the future work, I think Kaushik sir will be working on this. We will implement, he is going to implement two-step calculation procedure that is developed by Professor Biplav himself to rate the sentiment analysis system. And last thing but not least, my experience at internship was pretty good. For creating this tool using D3JS, I did not do much of web development after my junior year. So this reignited my passion for web dev, and I got to learn about various off-the-shelf and deep learning based SaaS. And on a lighter note, I also learned how to turn on a camera in a meeting, which I barely did on any of the earlier meetings. So that's it from my side. Thank you.
Thanks, Gaurav. Again, you can ask questions on the chat, and I will like Sparsh Agarwal to actually present his work now. Next.
Sure, sir. Sir, is it visible?
Yes.
Yeah. So good morning and good evening, everyone. So the topic on which I worked this summer was a generic dialogue agent for information retrieval that can flexibly mix automated planning and reinforcement learning. So here is my background and the context. So I'm Sparsh Agrawal. I'm a pre-final undergrad student from IIIT NR, Naya Raipur, India, major doing in some computer science, and my internship duration was of 3 months. That is from May 21 to July 21. And my mentors are Dr. Biplav Srivastava and Vishal Pallagni sir. My major areas of interest are problem solving, machine learning, NLP, and IoT. And the context for this internship was a dialogue system for information retrieval. So what is the problem explored? So as we know, nowadays there are widespread availability of data online. But due to this availability of so many data, it leads to importance of gleaning information and retrieving information from the data sets. But the common methods that are previously available are very tedious. It involves very tedious tasks such as SQL. It's a structured query language, which are neither effective, and it is also not accessible to all the users available there. So what we wish is to make our data accessible to users and and avail the information from them by using a natural interface of dialogues. So we present Prudent. It is basically a dialogue system that is capable of retrieving information from data sources. We have enabled this Prudent with reinforcement learning and automated planning. So basically, what planning is? It opt a task to reach a particular goal with maximum likelihood, so that we can reach optimally. So for now, we have tested our Prudent in two datasets, that is UNSPSC and ICD-10. This is the results and demo. For example, our approach offers the flexibility. We can even choose the data source we want to query. But since we have enabled it with reinforcement learning platform, so we can skip to select the data sources. It can automatically select. Now I can show you the demo. Is it visible, sir? Okay. So for example, sorry for this 96M. It's basically font crashing in Windows. It's working fine on Mac OS. Yeah. So suppose, for example, now I will use reinforcement learning program. I will just use automatic data selection. So I will just enter my query. So it is code for tongs. Basically, the data set that we use consists of a commodity, and that's I am asking for code for tongs. Since we have used reinforcement learning, so first it will search both the data sets and then calculate the reward function, and it will return the data set which gets the maximum reward, and then it will query from that data set. Yeah, so it's shown here that information that you are looking is available in directory UNSPSC. That is a data source that it's selected, and 6 instances found, and these are the possible code that you can look upon. So we can we can now further ask, give the, for example, if I will ask for dental tongs, I will just give 4 and it will give the code. This is clashing all over in Windows. It's working fine on Mac OS. So yeah,
Don't worry, Sparsh.
it's one of the drawback of Windows. So if we can also manually select the data source. For example, if I can manually select one, then again I will go for UNSPSC since we have already searched in it. So again I will search for code for tongs. So yeah, it will now give result much faster as we have already selected the data set. So yeah, we can continue to talk to the Prudent, or else we can wish to exit. So yeah, this is the thing. And what is the future is now we have to carry various experimentations on the various open data sources and calculate its robustness and effectiveness. Another thing is we also need to deploy this Prudent on the web server so that it can be publicly accessible. Now, talking about my experience at the internship was, yeah, I learned about one new thing, that was planning, which Dr. Biplav has asked me to do. Yeah, it was quite a very good thing that we can also work upon individually. And the next thing is, as Dr. Biplav always used to say, you should be more proactive. So yeah, we learned to be more proactive during this internship and get to know work within a particular given deadline. So yeah, thank you.
Sure. Thanks, Sparsh. I'd like to call Karan.
Hello, everyone. I'm Karan. Is my screen visible?
Yes.
Okay. So during my internship, I worked on an unsupervised system for exploring text documents. I am a third-year undergraduate at IIT Delhi in India. I major in computer science. So before my internship, I had been working on this problem with Professor Biplav for some time. My internship was during May to July 2021, and it is related to natural language processing. My mentors were also Vishal sir and Armu sir. So the problem explored is, let's say a user finds an unknown document on the internet and that they want to make sense of. So the document can be really long, it can contain multiple paragraphs, and not many people have the time to go through the document to understand it. So what they can do is they can either take the text or the URL of that document and uh, put it in our tool which we have created, and the tool will then output some insights which can help the user get started on the document. The type of document can be any news, survey, legal contract, financial report, or anything. Currently, we project documents into one of 7 domains. These range from politics, science, computers, recreational is sports, basically. Uh, um, a proposal, um, a research proposal, a person's profile, and others. So documents which do not fit into any of the other 6 domains are classified as others. We have used various NLP techniques in our tool, and I can show you a demo. Uh, so for example, I'm on the internet and I find this article about Jupiter, and I do not want to read the complete article. So what I can do is I can just take the URL. This is a website that we have developed, and I can just paste the link and query. So now the tool identified the domain as science. Here are some statistics. This is the word count and the sentence sentiment histogram. Now, if we move down, we have first of all an entity-centric view, an event-centric view, and a full text view. So I'll explain each of them. So for the top entities, we have the tool displays the top 5 entities. So for example, this article is about Jupiter, so this has to be the top entity. It shows the number of mentions, the type of entity, its location, and the general sentiment of words associated with it. Here's also a word cloud to visualize that. Additionally, we also have the actions on and actions by the entity. So for example, actions by Jupiter form, and we can now explore the meaning of form in the different domains that we have. So a verb can be a verb can mean different things in different domains. So for example, this is the general meaning of the verb, and here and below are some domain specific meanings that we have calculated from word embeddings. So this was a science article. We can also do it on people's profiles. So for example, this is the profile of Professor Biplav. It would just take a few seconds. Yeah, so it correctly identified the domain as a person. And the additional thing we have in this is this another column. So Professor Biplav Srivastava is a researcher. And what we have done is, since we have calculated the domain as a person, we can go through their Google Scholar page and get their top publications. So for example, these are some of the recent publications. And what we did is we took the titles of the publications and tried to have some standardized codes and terms which are related to the publications. So for example, we can see artificial intelligence as a major term in the professor's work. And we can also visualize the time series of how their research interests vary over time. Uh, Now for the experiments. So what we've done is
current 1 minute.
Okay, so we have also evaluated our system output on our data set of 100 proposals and 105 persons. So what we did is, to evaluate this, we have taken the top 3 top 3 terms that we see over here, and we presented them to users and we asked for their input. What do they think of the ranking of these terms? So they can go to the Google Scholar page or the proposal page and they can give their input of the ranking, and then we've calculated a score. So, and future outlook, we have submitted a research paper in the applied data science track of the CORDSCOMAT 2022 conference. Some of my key learnings were experimenting with different NLP and ML techniques and experiencing how actual research is done, and also writing a research paper. Overall, I had a very pleasant experience and gained a lot of knowledge. Thank you.
Thanks, Karan. Last but not the least, it is Sparsh from San Jose. Sparsh, you're on mute.
Hello. Is my screen visible?
Not yet. Not yet. Yes.
Hello. My name is Sparsh Johari, and I'm a high schooler I'm a high school senior at Evergreen Valley High School. I live in the Bay Area, and I have previously worked with the BERT model, and my interests in machine learning lie primarily with NLP. So I've been working with Mr. Biplav from July 20th to the July 2020 to the present, and I've been working on this particular project from June 2021 to the present. So the general domain of the problem that we were exploring was computational policy analysis and making laws more accessible to the general public. And within this general topic, we chose to focus on the GDPR. So the GDPR is the EU's data protection and personal data handling guide and set of laws that are implemented in the EU. And they have 11 articles, 99. They have 11 chapters, 99 articles, and 358 sections across the entire document, which, as you may imagine, is not exactly the most accessible way for for a layperson to just see if any given piece of text that they enter is in compliance with the GDPR or not, because it is a rather long and complicated document. So the problem that we were exploring was enabling users to better understand how potential actions that they may write about, whether it be through email or as a company policy or something like that, how that would relate to the GDPR guidelines. So we had several goals with this project, such as providing context for important terms that may be present in the document, providing a list of relevant articles from the GDPR so that they can understand what implications their words may have in relation to the GDPR, catching violations of GDPR guidelines, and providing easy access to the content of the GDPR so people can get a first-hand look at the laws of the EU. Oh, there we go. Sorry. Okay, so this was the general format of the tool that I designed. So you would enter text in this box here. It would give a list of terms here, and it would provide a list of about 15 sections that the tool feels is most relevant to the text out of the 358 possible options. And so here we can also enter terms and look for the places that they're found. And as here, we can get access to the original text of the GDPR itself. So I'll provide a live demo. Okay. So this is a piece of, oh, hold on, it's still. Okay.
Yeah, we can see it now.
Okay. Is text show? Okay, sure enough. So what I've done here is copy pasted some example text that I've been working with from a data set that I have been building in conjunction with an expert with domain knowledge in the legal field. So this is an example of text. And if you submit the text, you can see that it's found the word third party as an important term. Oh, hold on. It's still loading on the screen, I suppose. But it's found the word third party as an important term that it would provide further context for right here. And it's also provided this list of sections that are that it feels are relevant to the text. So that would be, say, chapter 3, article 13, section 4, and chapter 3, article 14, section 2, and so on and so forth. And if you were to look at the text, you could see that perhaps this has something to do with consent of the user toward, as far as their data is concerned, and what that means for automation. So you can look for where that's found in the GDPR, and you can also see where that term is present within this within the original text of the GDPR to get more context for what this text might mean for this piece of text here. Okay. So just examining further how these results relate to the original text, what we can see is that Article 14 regulates what information must be given to data subjects when they themselves are not giving up their personal data, but instead it's being collected from a third-party source. And so it's important to note that compliance issues predominantly arise from Article 13, not 14, which as you saw previously, Article 13 was the most relevant, and then that section from Article 14 was the second most relevant result. But additional information would be needed to determine the applicability of Article 14 in analyzing this given text that we saw for GDPR compliance. So some areas of improvement where this model could be made better would be, firstly, increasing the relevance of the top results yielded by the model. In the example that I showed, the results were more or less relevant for the top two results were pretty relevant to the text. But with other pieces of text, the results are somewhat more hit or miss. Like in the top 30 outcomes, you might find that some would be not as relevant, but be ranked higher. So improving that ranking process and improving the relevance of those top search results would be a way to improve the model. And the way that we could perhaps go about that would be maybe increasing the sophistication of the embedding process that was used to embed the text of each article section. And another way that we could perhaps improve this would be to use more complex models other than the TD-IDF model and have more complex evaluations of similarity besides cosine similarity. So the TD-IDF model worked much better than all the other previous models I was attempting to use, but because it is more complex, but using something like, say, BERT or GPT-2 might be a more effective way to make sure that the results we're getting match precisely with the expectations. And one of the goals that I mentioned previously was evaluating compliance. I was not able to get to this goal within the time frame that I've been working on this project so far. So a future goal would also be to evaluate the compliance of the given text in addition to finding the relevant articles. And this would also involve making a larger data set of examples of text that may or may not violate the GDPR guidelines. So throughout this internship, I've gained quite a bit of experience. I've learned how to use the TD-IDF model for NLP, and I've also come to understand both its strengths and its limitations. I've also come to better understand the layout of legal documents like the GDPR, which hopefully would translate to an easier time doing computational policy analysis for other documents, like, say, the California data protection and consumer privacy protection rules. And lastly, I've also gotten more experience creating user-friendly interfaces and something that's more interactive. So these are 3 avenues of knowledge that I have gained throughout this internship. And overall, it was a pleasant experience. And I just want to thank Mr. Biplav for giving me the opportunity to work on this project.
Okay. Thanks, Persh. Just one couple of things you missed. One, it is TF-IDF, term frequency, inverse document frequency, not TD. Second, you were co-advised by Network from Adobe. as well as Marilyn Gartley from the university, who's our legal expert. Okay. All right. So, guys, you saw all the presentations. So there were 7 students who actually worked on this. Any questions or comments anyone has? Excuse me.
Yeah. My question is actually for our most recent presenter, Sparsh. I guess this just might show a little bit of my unfamiliarity with the NLP field. But I saw that section, it was really cool. The interface where it has the sections related to the text. How were those results